Welcome to question number 35 from the August 2015 Geometry Regents exam. So this question is a proof, and we're trying to show that the parallelogram ABCD is a rhombus. So the strategy we're going to go for here is to get to the point where we can say that the line from B to C and D to C are congruent or equal in length. Because if we can do that, that's enough to prove that it's a rhombus. Because if you've got a parallelogram with consecutive congruent sides, it has to be a rhombus. So how do we get to that point? Well, we utilize these two triangles. There's a reason those lines inside this parallelogram are drawn. It's because there's two triangles formed. See, there's this green one, and then there's this blue one. So if we're able to show that these two triangles are congruent, then we could conclude that the length from B to C and DC are equal. Let's start by comparing let me change the pen here, the two 90 degree angles that we know. We know that the line DF and BFC are perpendicular, so that's going to be 90 degrees. And we also know that this angle here is going to be 90 degrees. So we can conclude that those two angles are going to be congruent because they're both 90 degrees. Now the next important thing to note with these two triangles is that they both share the same angle here at point C. So within the two triangles, we can say that they are congruent, and this is just basically because of the reflexive property. They both share that same angle. Now the third and final component that these two triangles share is given to us in the original question. We're told that the lines CE and CF are congruent, so these two distances are the same. So now we're dealing with two triangles that are congruent based on the angle side angle theorem. Now that we've effectively shown that we're dealing with two congruent triangles here, we can now say that the lines from B to C and C to D are congruent. And the reasoning behind that is because corresponding parts of congruent triangles are congruent, or my favorite acronym, CPCTC. And we've done it. We can now conclude that ABCD is a rhombus, and that's because we've got a parallelogram with consecutive congruent sides. Okay, so I hope that proof helps, and that's it for this video. Thanks for visiting JD's Regents Preparation.